Let's take a look at number 3. So in number 3, as we look at this equation, our first goal will be to look at this and ask ourselves, how do we achieve? So we have a picture here of a diver. He's going to jump into the water. We want to know what is the height when he jumps. So that is your initial height. That is always going to be your constant. So we're at 32. That is going to be at 32 is going to be the height above our water, 32 units above. Now, what is the height? What is the height of the diver when he is at his maximum height? So maximum height for this, so our maximum height is, we want to know what is this point here. So maximum height is going to have two different terms here. The first is going to be a height, so this is going to be units above ground, and then this is going to be the time it takes to get to that point. So x and y, x represents time, y represents height. So what is the maximum height? I want to know the y value. Well, let's first figure out the x. Negative b over 2a. We can see that way up above. If I'm able to pull this down, right down here, it even provides us with that. So if I'm going to put negative b over 2a, and my b value is a positive 16, so negative 16 over 2 times a, which is negative 16. We can see again, my a is negative 16, my b is positive 16, and my c is 32. So if I come right up here and I reduce this, I get an x value that's negative 16 over negative 32. Well, that reduces to positive 1/2. That is the time. So it takes a half of a second before the diver reaches the maximum height. But I want to know just what's the maximum height. What's the y value at this point? I know the x value is 1/2. What's the y value? So I'm taking the 1/2 and I'm plugging it back in. So negative 16 times 1/2 squared plus 16 times 1/2 plus 32. Okay, you ready? So I know that this is equivalent, if I take time to do it down here, this is going to be 1/2 times 1/2. So 1/2 times 1/2 plus 16 times 1/2 plus 32. All right, and we're going to go after the value I'm able to achieve is going to be the height, the maximum height. 1/2 times 1/2 is 1/4. That means negative 16 divided by 4 would equal negative 4. And then 16 times 1/2 would be 16 divided by 2, which is positive 8, plus 32. Negative 4 plus positive 8 is positive 4, and 4 plus 32 provides with this answer of 36. So 36 units above the water is when he hits his maximum height. He leaves at a height of 32, hits a maximum height at 36 above. And now how many seconds before it actually hits the water? We want to know, when does it actually hit the water? So I'm going to come back up to this. I'm going to set this equal to 0. Negative 16, I'm just going to write it as x, plus 16x plus 32. When does it hit the water? We could use the quadratic formula. Myself, I recognize I can factor out a negative 16. I'd be left with 1x squared minus 1x minus 2. Now let's make sure this is right. Negative 16x squared, positive 16x, positive 32. Okay, what multiplies to equal negative 2 and combines to give us a negative 1? Okay, they're different signs. The larger one is negative. So negative 2 and positive 1, they multiply and they combine. Because the leading coefficient is 1, we get to be really lazy. X plus 1 and x minus 2. Now, if this doesn't have an x, we just factored out a value. We don't need to worry about that when we're actually solving for 0. So I'm going to take each one of these and set it equal to 0, and I'm going to solve. One answer is negative 1. The other answer is positive 2. Now, let's make sense of this. So we can see if we think of this as the origin, we can have 1 here at negative 1 and 1 over here at positive 2. Now, the diver is not jumping backwards into the water, he's jumping forwards. So we can't have a negative value of time when you think about time on the x-axis. We can only have positive time for how long does it take for you to move forward until we hit the water. So how many seconds can we assume until it hits the water? 2 seconds. Again, this is all done here without a graphing calculator.